Okay, next what we're going to do is graphing ellipses not centered at the origin. When an ellipse is not centered at the origin, we can still use the standard forms to find the key features of the graph. When the ellipse is centered at some point, hk, we use the standard forms x minus h squared over a squared plus y minus k squared over b squared is equal to 1, where a is greater than b for horizontal ellipses, and x minus h squared over b squared plus y minus k squared over a squared is equal to 1, where a is greater than b for vertical ellipses. From these standard equations, we can easily determine the center, the vertices, the co-vertices, foci, and positions of the major and minor axis. So, given the standard form of an equation for an ellipse centered at hk, sketch the graph. Number 1, we use the standard forms of the equations of an ellipse to determine the center, position of the major axis, vertices, co-vertices, and foci. So if the equation is in the following form, where a is greater than b, then the center is going to be located at hk. The major axis is going to be parallel to the x-axis. The coordinates of the vertices are h plus or minus a, k. The coordinates of the co-vertices are h, k plus or minus b. The coordinates of the foci are h plus or minus c, k. If the equation is in the following form, where a is greater than b, then the center again is at hk. The major axis is parallel to the y-axis. The coordinates of the vertices are h, k plus or minus a. The coordinates of the co-vertices are h plus or minus b, k. And the coordinates of the foci are h, k plus or minus c. Step number 2, we're going to solve for c using the equation c squared equals a squared minus b squared. And then 3, we're going to plot the center, the vertices, the co-vertices, and the foci in the coordinate plane, and then draw a smooth curve to form the ellipse. So in example number 5, we want to graph the ellipse centered at hk given by the equation x plus 2 squared over 4 plus y minus 5 squared over 9 is equal to 1. And then identify and label the center, vertices, co-vertices, and foci. So step number 1, we first need to determine the position of the major axis. So because the denominator for the y is 9 and it's greater than the denominator for x, which is 4, then we say the major axis is parallel to the y-axis. So therefore the equation is in the following form, where b squared is equal to 4 and a squared is equal to 9. So we now know that the center of the ellipse is going to be at hk. Well, it's x plus 2, so the value of the x-coordinate is negative 2, or what h is equal to. And the y-coordinate is going to be the value of k, which is y minus 5, so it's going to be positive 5. So it's going to be centered at negative 2, 5. Now the coordinates of the vertices are h and then k plus or minus a, which is negative 2, comma 5 plus or minus the square root of 9. Well, the square root of 9 is 3, so it's negative 2, 5 plus or minus 3. So we have negative 2, 2, and negative 2, 8. The coordinates of the co-vertices are h plus or minus b, k. So it's negative 2 plus or minus the square root of 4, 5. Well, that becomes negative 2 plus or minus 2, 5. So we have negative 4, 5, and 0, 5. The coordinates of the foci are going to be h and then k plus or minus c, where c squared is equal to a squared minus b squared. So plugging in a squared to be 9 and b squared to be 4, we got 9 minus 4, and we get c, which is equal to plus or minus the square root of 5. So therefore the coordinates of the foci are negative 2, 5 minus the square root of 5, and negative 2, 5 plus square root of 5. Then we're going to plot and then label the center, the vertices, the co-vertices, and the foci, and then draw a smooth curve to form the ellipse. So we determined that the vertices are at negative 2, 2. So there's negative 2 and then 2. And then we also have vertices located at negative 2, 8. Now the foci is located at negative 2, 5 minus the square root of 5. And then negative 2, 5 plus the square root of 5. We know the center is going to be located at negative 2, 5. We know that the co-vertices is at 0, positive 5, and negative 4, positive 5. And then drawing our smooth curve forms our ellipse centered at negative 2, 5.